Good afternoon, everyone. Welcome to our session, Making Compliance Cloud Native with GKE and GCP. My name is Zeal Somani, and I'm a security and compliance specialist with Google Cloud.
I'm Wallace. I'm a security lead with Google Cloud Professional Services.
And I'm Claudia Duma. I'm security architect at Credit Suisse.
So today we'll be talking about how to modernize regulated workloads and at the same time meet your compliance requirements. So when we look at regulated workloads, they are quite challenging and complex. Why? Because there are multiple stakeholders involved, right? You have the makers and the checkers, makers who build cool products, your developers, your enterprise architects, and then we have our checkers, our CISOs, our risk and compliance people, our legal. Number two, these workloads have to meet stringent compliance requirements, and most of these workloads are legacy. So in this talk, we want to enable our makers and checkers on how to modernize those workloads and at the same time keep meeting the compliance requirements. Now, as the regulated workloads are primed for modernization, our makers, they love cloud-native technologies such as containers, mainly because it allows them to break down a large monolith into smaller microservices. And two, it allows them to deploy in a multi-cloud or in hybrid fashion. Our checkers, they love them too, because you can inherit a lot of security defaults from your cloud provider. And you can also do blue-green deployments, wherein you can have multiple production environments, and that reduces the risk of a downtime. However, not everything can be hunky-dory, right? In a regulated space, any conversation is incomplete without a regulator or an auditor in light. So that brings us to regulatory audits. They are cyclical or seasonal, and they can really make our checkers and makers and checkers a little bit anxious or uncomfortable. Because audits are quite daunting. Most of the compliance frameworks were written long before cloud became a thing, so they're not cloud native. It takes a village to pass an audit with so many stakeholders having to meet these compliance requirements. Cloud is new, people working on them are new, so there is a fear of misconfigurations and to rectify it before the audit is completed. And then evidencing the shared responsibility, which can be challenging as well, especially when you are in a multi-cloud or an hybrid environment. With that, I would like to invite Claudia from Credit Suisse on their experience in the regulated space.
Thank you. Choices. Made it work. So, as a security architect, I'm involved in defining security strategies and security best practices for our internal cloud and public cloud initiatives. As per Zeal taxonomy, I'm probably somewhere in between a maker and a checker. A little bit about Credit Suisse. Founded in 1856, Credit Suisse is today a leading global bank and one of the largest banks of Switzerland with business operations in more than 50 countries. Now, Credit Suisse is also an IT company, you can say. I mean, we have several thousand people working in IT and application development. We manage a portfolio of over 3,000 applications, which are running on several tens of thousands of servers in our 4 data centers hub across the world. So we are managing a large estate which has grown over decades, and as it happens, has also grown in complexity. So now, for us, as for any other organization of our size, cloud is a challenge. I mean, it's a good challenge, because it is challenging the way we build, we operate, we use IT. And with containers, with platform as a service, with open source, cloud is bringing standardization and eventually reducing complexity. With infrastructure as code, with services on demand, it is reducing the effort for operation, as well as bringing up cost optimizations. And last but not least, with ready-to-use services, advanced services like machine learning, AI, data analytics, cloud is actually freeing people from managing infrastructure and allow them to focus on improving productivity, improving business value. Therefore, for Credit Suisse, cloud is a pillar of our IT and business strategy. So one of the questions is, how do we bring the bank to the cloud, to the public cloud? So when moving to the public cloud, it is important that we meet our internal security policies and security standards, as well as we are compliant with our regulators. In principle, the security posture, the security and risk posture that we would get in the public cloud should be the same, at least as we have on-prem, if not even better. Interestingly also is that the requirements per se are kind of the same. But what's changing is the way you address them, the way you build security, right? So in principle, I mean, when we were looking at the problem, we saw two major options, so to say. I mean, are we going to take our security ecosystem from on-prem and try to push it into the public cloud? And with that, actually also bring the whole complexity, or rather think a little bit more cloud-native, cloud-ready? And actually, our strategy and also our security strategy is to think cloud first when we're thinking about public cloud. And with that, we actually want to reduce the complexity, to simplify actually our security controls. And sometimes actually even maybe removing some of the decades-old problems that we've had. And an example I'm thinking of is privileged access management. So that's actually a really big pain for any big organization in the world, right? Now, with containers and with the cloud-native, cloud-ready technology, in principle, nobody should have SSH RDP access in production. I'm talking about administrators with interactive SSH access. Nobody should have that type of access. Any change to the production environment should be moved to the left and deployed via well-established, automated, and verifiable CI/CD pipelines. One note I want to make is that it's not that you can't leave behind your security ecosystem from on-prem. You can't do that. And the reason is that some of the processes, for instance, around identity and access management, they have also grown over the years, and they have grown from the requirements of your regulators. All those processes are in those tools, like, for instance, joiner, mover, lever, sensitive movers, and probably these names don't tell you much, but for those acquainted with FINMA regulations, tell you a lot. So what else is needed, and what we got with Google, is also ensuring that we have a good integration of what we do on-prem and what we would do in the cloud, via federation, via directory synchronization, and more. So share responsibility. Now, we are all familiar with this. And as a bank, and per the model, we might manage only part of the stack, the upper part of the stack. But to our clients, to our shareholders, and to our regulators, we are actually accountable for all of it. So how do you achieve that? You do need to have a good collaboration, a good, strong partnership with your cloud provider. And this is what we actually achieve with Google, right? So on the top part, GCP is giving us the tools that we need to actually build a secure environment in GCP. As I mentioned, it gives us the integration capabilities with the Cloud IAM, with the Federation, and much, much more, right? But then, on the bottom part of the stack, we also need to ensure that GCP's security posture, security operations are in line with actually our requirements and our regulatory requirements. So we achieve that by assessments, actually many of them quite tedious assessments, so thank you Google for carrying with us, audits, and obviously contracts. So, oops. So let me tell you a little bit about some of the key challenges that we faced when implementing a machine learning solution, machine learning platform in GCP, right? So we are a Swiss bank. For any Swiss bank, the top of the list always is data residency, data sovereignty. And that's where actually, with the launch of the Swiss region of GCP in March, that was the first step to a partnership, to a collaboration. Now, obviously, we are protecting data at rest in the cloud. We are using bring your own key, and we are storing and managing those keys in HSMs. And we do that as per, actually, Swiss guidelines, Swiss Banking Association, sorry. We are also having extensive logging, and all those are centralized and bring into the monitoring. We are using the access approval, for instance, to ensure that we have control, that we are in the loop if, for instance, we require a GCP engineer to get access to our services or to our data, right? And one of the biggest problems, besides the data sovereignty and auditability when moving to the cloud, is actually data exfiltration. Majority of breaches in the cloud happen because of data exfiltration and happen because misconfigurations. This service or that service or the other service. And this is because it's very difficult for a company to actually define precisely what are my boundaries. Because the boundaries in the cloud are not any longer your network boundaries, not even the virtual network boundaries, right? So there is where VPC service control, we found it as a very elegant solution to a very difficult problem, right? So with the VPC service controls, the ones that know it, you know that you can define your logical perimeter, right? And that logical perimeter has VMs, has containers, also has those services that you might instantiate, like storage and so forth. What's within your perimeter doesn't leave the perimeter. And that's very, very important. And now, as I said, I'm not a maker, so I'm not going to be able to give you a demo of what we've done. But I'm an architect, so I'm giving you an architecture diagram. And then look at the details. What's important here to understand that, first of all, we've integrated this with actually our on-prem identity and access management via Active Directory. But most importantly, again, I like to direct your attention to that VPC service control, for instance, to just see like how beautiful is bringing together everything, all the constructs that belongs to Credit Suisse and are there in the cloud, right? So I've given a little bit of a controls perspective on how did we create the overall environment, the landing zone. And now I'd like to hand back to Zeal to give us a little bit of understanding. How do we make sure that, that what we deploy is actually secure?
Thank you so much, Claudio. Perfect. So thank you, Claudio, again, for this, this wonderful architecture diagram of the landing zone. Now let's pivot to containers or more cloud-native technologies, right? Starting with containers. Here at Google, we really love them, mainly because of these unique properties that they present. Google's internal infrastructure has been containerized, and after being containerized, we've noticed that our security as well as our reliability has improved. Kubernetes takes inspiration from Google's internal container orchestration system, Borg. So let's look into these unique properties. Number one, they are declarative. So you can define a known good state as you're building a container. Number two, they are inspectable. So you can statically look at a container when it is running to ensure it is running in a known good state and it is not deviating from it. And lastly, they are immutable, meaning you cannot change a container once it is deployed. If you have to patch a container, you have to rebuild it, which is fundamentally different from a mutable infrastructure such as a server or a VM. And we'll walk through all of this later in our section on secure supply chain. So that brings a new security model. As you're building your containers, you want to build from trusted sources. You want to have good security checkpoints along your CI/CD pipeline. And then you want to codify your security requirements as early as possible and shift left. That also brings a new approach to compliance. As you're building your containers, you want to think about compliance of the infrastructure on which you're building the containers. You want to think about the compliance when the container is running, which is at the runtime, and then over time to ensure you are in compliance across the life cycle of that container. So I've talked a lot about compliance requirements, but what are they? So what we've done is we've taken some common compliance frameworks such as PCI DSS, ISO 27001, NIST, and we've looked at the technical requirements, technical sections within each of these frameworks. And what we've noticed is that these requirements, they fall in these 5 categories. And our remainder of the presentation will cover each of these. So let's get started with segmentation and networking. Now, segmentation is usually not presented as a compliance requirement, but it is a best practice. It is your opportunity to work with an auditor to clearly say, hey, this is in scope for my assessment versus this is out of scope. And when you have proper segmentation in place, when you have proper networking controls in place, your audit will go really fast. Segmentation from a container perspective is mainly segmentation around or outside a container, and segmentation within a container. And then there are other networking requirements such as DDoS and WAF protections. So before going into details, let's do a quick refresher on what is inside a Kubernetes cluster or the ingredients of a cluster. You have the etcd, which stores the state of the cluster. There's a master, which controls the cluster. And then you have the actual node, which is the machine that runs the pod. The pod is nothing but a collection of containers. A common question I get is, can I have different profiles of pods running within the same container, meaning a PCI pod and a non-PCI pod in that same cluster? And yes, you can if you properly segment your cluster. Who protects what? Everything on the left is protected by Google, and you're responsible for the nodes and the workloads. So let's pivot to segmentation and how you can define that boundary, going back to Claudio's point. At the macro level, around the cluster, you can segment your users using projects and folders and the cloud IAM, the hierarchy that you define. Subnets helps you to segment your network. And then VPC service controls to do that logical boundary around your applications. And then within the cluster, you would do the things which are in red, which let's double click on it. So to understand segmentation within a cluster, let's let's understand how networking within a cluster works. So each pod within a cluster gets its own IP address. To segment the pod, you should use network policies. Network policies is very similar to VPC firewall, so you can create allow deny rules based on IP addresses. Let's build upon the segmentation. Now that you've segmented the pods based on IP addresses, you want to segment certain application based on teams, such as production and sorry. You want to segment the pods based on certain teams, or you want to segment the application based on different profiles. This is where you would use a namespace. Another common requirement that is presented is to protect the private IP address or the routing information. This is where you can mark a cluster private. Marking a cluster private makes the master inaccessible from the internet. And you can also mark that cluster regional to meet your regional requirements. So all in all, starting with network policies, segment at the layer 3, GKE namespaces at the team level or at the application level, private clusters to hide your IP information, and then top it up with the service mesh. And to wrap up this section, I also want to mention IAP and Cloud Armor. With IAP, you can enforce context-aware access through trusted IP ranges or trusted devices into your in-scope environment, and use Cloud Armor for DDoS and WAF protections. Moving on to identity and access management, another common requirement across most of these frameworks. So identity and access management is mainly around, has requirements around mainly the 3 A's of access, which is authorization, authentication, and audit, for human accounts, and service-to-service communication. And you want to limit the access to your in-scope environment on the basis of principle of least privilege. So how to achieve these 3 A's? You should use the GCP IAM and Kubernetes RBAC, Kubernetes role-based access control, to address the 3 A's of the access, and to enforce requirements such as multi-factor authentication or 2-factor authentication. GCP IAM as well as Kubernetes RBAC can send the logs to Stackdriver or your logging infrastructure, and then we'll be again covering a whole section on logging and monitoring. So use the IAM at the project level to set the cluster boundary or access around the cluster, and then RBAC at the sub-project level. So IAM and RBAC works for human accounts and service accounts. Now let's pivot to service-to-service communication. A common requirement which is presented for microservices architecture is to have every service-to-service communication encrypted as well as mutually authenticated. And this is where something like a service mesh really helps. So what is a service mesh? Or what is Istio? Istio is this open framework with which you can connect these microservices. Istio, again, has a lot of inspiration from Google's internal systems, and it supports VMs as well as containers. So let's walk through this example of a microservices-based architecture and how to work with an Istio. There is a front end, and there are a bunch of back-end microservices. There is Cloud SQL for user management, and there is an external payment processor which is connecting to the overall application. Now, each of these services, it has a proxy running in parallel with it. So that is that purple hexagon. So all the traffic going in and out of that workload can be captured by that proxy, the purple hexagon, and you can do some really cool and interesting things with it. One of the interesting things, as I mentioned before, is to ensure that the connection between 2 services is always encrypted and is mutually authenticated. And to do that, the proxy needs to have a control plane. So Istio over here has this control plane. There are 3 components within that control plane: pilot, which pushes the routing information, Mixer, which is the one in the middle, with Mixer, you can say which service can talk to which other service. And Citadel is the security component in the service mesh. It's the it's the CA, or the certificate authority, that issues identities and certificates to each of the services. So now in our example, the front-end service will be able to talk to the back-end service, the payment service, as long as the payment service presents its signed certificate claiming who it is, and vice versa. So that's how you get a mutually authenticated connection and encrypted connection between services. Let me hand over to Anne for the remainder of the presentation.
Thank you, Zeal. So now let's talk about data security and data protection. So some of the things that you might hear from your auditor are encrypt all the things, well, almost all the things, get rid of data that you don't need, and then make sure your data stays put. So in this section, we're going to talk about data at rest, data at flight, and then some specific use cases around secrets and crypto shredding. So building on the IAP and Cloud Armor slide that Zeal presented in the networking section, let's talk about data in flight. And data in flight here, I'm talking about data coming from the internet into your cluster. Zeal already covered within your cluster using Istio and MTLS. So this really isn't that much different than how you would encrypt traffic going to your VM. So you can still use Google managed SSL certificates to manage, provision, and renew your domain certificates. And you can also use these certificates with HTTPS load balancers. The difference here with GKE is you use ingresses to create HTTPS load balancers with automatically configured SSL certs. So the example on the left is managed certificate resources, and then the example on the right is the ingress manifest. Okay, so YAML really isn't that cool, but as far as compliance goes, the YAML used for declaring your Kubernetes configs plus your Git workflow is self-documenting, meaning that you don't have to do anything differently to track who did what when. Your change history can be tracked through your Git history. This obviously isn't just for your load balancers. This applies to any changes in your cluster managed the same way. So data at rest is encrypted by default for all GCP products. So data is encrypted prior to being written to disk. Each encryption key itself is encrypted with a set of master keys. And then encryption policies are managed in the same way in the same key store as Google's production services. But sometimes we know that you need more than default encryption. So this might be for your secrets, or you might have requirements to manage your own keys. So you can use Cloud KMS, or Customer Managed Encryption Keys, or CMEK. This allows you to create, use, and revoke the key encryption key, the green one, but Google still manages the data encryption key. So let's take a look at how this envelope encryption works when you use Cloud KMS. So the red key, the data encryption key, encrypts the data. The green key, the DEC, the data encryption key, the key encryption key, the green one, encrypts the data encryption key. And then the encrypted data is encrypted, and the encrypted data encryption key are stored together. Hopefully you got that, because I stumbled through that one. But cool. So now let's talk about specific use cases where default encryption might not be enough. So one might be sensitive data. So with sensitive data, you might have requirements where you need to manage your own encryption keys and rotation. So again, in that case, you can use Cloud KMS and Customer Managed Encryption Keys. And you can use this with persistent disk attached to your nodes in your cluster. But boot disk and control planes cannot be protected with CMEK. The second use case is secrets. So we consider secrets credentials, configurations, APIs, or other sensitive information that you might need at build time. So you might say, aren't secrets already encrypted in etcd? They're not. They're base 64 encoded, which is not encryption. So anyone with access to your etcd database or backup to that has access to your plain text secrets. So let's take a second to see how this looks. So an app submits a secret to the Kube API server. The Kube API server pushes that into etcd in plain text. And then if an attacker has access to your etcd or backup of the etcd database, all your secrets are now available to them. So we offer application layer secrets encryption for GKE. So the TLDR here is that you can use Cloud KMS to encrypt your secrets in etcd. So going back to that previous slide, let's look at what that might look like. So again, your app submits a secret to the Kubernetes API server, but before the Kubernetes API server pushes that secret into etcd, it is encrypted with Cloud KMS. And then it is stored encrypted in etcd. So even if an attacker gains access to the master nodes, the encrypted keys are still managed by an external system, so that means they can be rotated and managed externally. So again, the attacker would be able to get the secret, but it's in ciphertext and would need access to KMS to encrypt that, decrypt that. So crypto shredding. This is actually really easy if you're using Cloud KMS. You simply revoke the key encryption key, and then the data is irrecoverable. OK, so let's go into supply chain. So in this section, we'll address questions and requirements around making sure your containers images are vulnerability-free, ensuring the images that you deploy into production are trustworthy, and the lifecycle management of your containers. So let's take a minute to talk about what a software supply chain is. So as humans, we think about our food, and maybe more specifically our food supply chain. So we ask questions about what are we eating, which country does it come from, is it organic, and so forth. And as developers, we think about our software in the same way. We're interested in the origin of the binaries we're deploying. Where does the code come from? Is it vulnerability-free? Does it meet my compliance requirements? And all, how do I manage the central governance process without slowing down my development speed? So with older architectures and environments, it was really challenging to build security into the supply chain. But with cloud-native technologies, this is where I really think the magic comes in. We've been thinking about security from day one with regards to the supply chain. But so, traditional VMs, many organizations run giant monolithic applications, and it gets updated a few times a year due to the complexity of these applications. And for each release cycle, security and compliance stakeholders are involved, and they have checklists, and they manually have to probably go through these through this development process. It's a very human, heavy-based process. A lot of people have access to production environments, and then the security model is very reactive. But at each stage of the software supply chain with GKE, we provide solutions that help you apply security and meet compliance requirements while maintaining release velocity. So while you're developing and building, you can use base images that are maintained and regularly patched by us. As your container images are built and pushed into container registry, they're scanned for known vulnerabilities and categorized based on CVE rankings. This is a common compliance requirement. And then at the deploy stage, you can use binary authorization to create deployment policies based on your container image metadata. And then as your service is running, we continue to ingest vulnerabilities, so you can be notified if your containers now have new vulnerabilities or are affected by vulnerabilities. So maybe you have a requirement that says establish a process to identify security vulnerabilities and assign a risk ranking, maybe like high, medium, and low. So you can use container registry vulnerability scanning. It checks the images that you push into the registry for security vulnerabilities. And we currently support multiple OSs like Ubuntu, Debian, Red Hat, CentOS. And it constantly refreshes the vulnerability database from feeds from the corresponding vendors, so you can be notified when there are new known vulnerabilities. It also supports PubSub, so you can integrate this into your CI/CD pipeline, notify your teams, or create bugs for new vulnerabilities. So another common requirement that you might have is establish that all systems and software are protected from known vulnerabilities. So again, you can use binary authorization here. So this can help you ensure that only properly signed containers are deployed into production or other environments. So you create deployment policies. So these policies can be based on things like attestations from the vulnerability scans or other kinds of signatures. So maybe something that has to be built in a particular pipeline or have gone through a specific QA process. And so again, this ensures that only trusted images are deployed into your environment. This doesn't guarantee that vulnerabilities are not in your container images. It simply helps prevent, based on policies, that things don't get deployed into environments. So to walk through, maybe you need to walk through your auditor or your compliance team through this whole process. So you would first talk about you check your code into something like GitHub or your source code repository. That then kicks off Cloud Build. Cloud Build will then generate your container images, and it has a build record, which contains information like from the image, including like the location of the source code from which it was built. And then the container image will get scanned by vulnerability scanning. And then the results of that scan are part of the image metadata as well. And then, as mentioned in previous slides, you can use binary authorization to require things like attestations based on the vulnerability, maybe to prevent images with something, say, like high vulnerabilities from being deployed in production. You can also have requirements like only allowing images from trusted sources from being deployed. And then if someone tries to actually deploy one of these unauthorized images, it'll get stopped by binary authorization, and all this is logged into Cloud Audit Log. And so now logging and monitoring. So I've mentioned Cloud Audit Log a few times, so we'll get into that a little bit more here. So I think logging and monitoring can be a little bit overwhelming sometimes. So yes, you need to log all the things, but there's specific things that you need to log and monitor. You need to be able to track all the events back to an actual user. And then you need to log for security events. And then your logs must contain specific information like the user, event, date, and time. So many logs don't really change significantly for containerized environments. So for example, network logs look pretty much the same as long as you can tie an IP address back to a single pod rather than the node it's running on. So there's a lot of logs that you're going to be collecting in your environment, but we're going to focus on some of the key ones: infrastructure logs, Kubernetes logs, operating system logs, and application logs. So when I talk about infrastructure logs, I'm talking about the logs that you get from us. So these are the Cloud Audit Logs or things like VPC flow logs. So Cloud Audit Logs contain the CRUD activities that you're making to our API. So create a VM, delete a cluster, and so forth. These also contain things like quota warnings, errors, and debug information. So above me, there's a sample of a Cloud Audit Log. It includes information about the request, like the type of operation, how it's authenticated and authorized, and then information about the content of the request, like the version of the GKE cluster. Next up is Kubernetes logs. So Kubernetes audit logs are actions taken in Kubernetes. A given request will generate events at multiple points in the lifecycle. So one, when a request is received, when a response is started, and then when the response is completed. The Kube API server processes events according to your audit logging policy and will then log them. And just like other types of logs, Kubernetes logs can be logged at different event depths of detail based on the information that was included. So operating system logs. So when I'm talking about operating system logs, I'm talking about the operating system on your node, not the operating system of your container. So this contains information like network connection, user logins, certain executions, like maybe how the Docker is executing the containers. And to collect these logs on Kubernetes, you deploy a logging agent as a daemon set like FluentD, and then you have that write it to your logging infrastructure. So maybe Stackdriver or Elasticsearch and Kibana. And so lastly up is application logs. These are logs coming from your application, including errors and warnings, and these really aren't actually that different for containerized environment, but how you collect them might be. Actually, it's really simple. We just went over it in the last slide. You deploy a logging agent as a daemon set, collect the logs, and poof, write them to your logging infrastructure. So now let's look at this together. Where do logs come from? Where do they go? So again, the infrastructure logs are coming from us, and so those would go into something like Stackdriver. And with GKE, we also automatically write your logs to Stackdriver. And then your operating system logs and your application logs, you can collect yourself with a daemon set like FluentD and then write them to Stackdriver or some other logging infrastructure. So now you have all the logs, now what? So there's things like you need to monitor them and you need to look for certain security events. So I've mentioned Stackdriver a few times, and with GKE, the metrics and logs are automatically pushed from your cluster to Stackdriver unless you explicitly turn it off. So Stackdriver for GKE aggregates the logs, events, and metrics from your environment to help you understand your application's behavior more. This also allows you to create custom monitoring dashboards and alerts, such as alerting on specific Kubernetes audit log events. Note that the logs are only kept for 30 days, so you probably want to push them elsewhere for retention. So you can export logs externally to like cloud storage, PubSub and BigQuery. So again, you can do this for retention or maybe advanced analytics of your logs. Stackdriver can also be used with more than GKE. You can use it with all our GCP products. You can also pull in from other resources, maybe other cloud providers, so you have all your logs in one place. And so now you have these logs going to a central location. You want to start monitoring these. So through Stackdriver, you define policies. These are essentially state descriptions and response patterns. So these policies are defined using the following. One, a condition. These are the circumstances or observable states to trigger further action. And then a time duration, a duration window. So this is the time frame with over the condition must exist to warrant further action, and then notification. So there's multiple ways for notification. You can do this with Slack, SMS, PagerDuty, or send it to maybe a custom remote web service. And now you have all that in your monitoring, but you want to start detecting for security-specific events. So you could use machine learning on your audit logs, or to detect rogue behavior, or you can use something like event threat detection. So with event threat detection, it automatically scans your Stackdriver logs for suspicious activities. So things like data exfiltration, malware, crypto mining. When a threat is detected, it's surfaced in Security Command Center. So this enables you to start correlating the findings with other suspicious activities. So maybe application vulnerabilities or misconfigured control access policies. So to sum up the last 5 sections, security controls for compliance don't really change that much with cloud-native technologies. But in some cases, compliance actually becomes easier. So now all these people are happy, including your auditor. The TLDR in this presentation, and yes, I could have started with this, but you might not have stayed for this whole presentation, is 1, I think Kubernetes makes compliance easier in a lot of places. In some places like logs, it's pretty much the same. Teach other people what you know. You want to make cloud-native security and compliance less scary. 3, understand the shared responsibility model between you and Google. And then automating as much as you can with makes compliance less burdensome, and then you have that audit trail. These are some resources that we mentioned throughout the presentation. I think there's some other sessions that you might want to attend that complement this one while you're here. And make sure you rate our thing. We're supposed to say this, but we appreciate you all coming during lunch, and thank you very much, and we'll be available for questions after this.